Hi, here we are discussing about a project FPGA implementations of intelligent elevator systems for AI applications. Here, the intelligent elevator systems are used in many smart buildings, offices, hospitals, and tall apartments to move people quickly and reducing waiting time and save human energy. It have many advantages like a faster operations, a better safety, and its ability to handle a request from many flows at the same time. But are some disadvantages such as a slow response when the people use them, the fixed moment patterns that cannot adjust to real time needs, and weak security for restricted flows, and no use for advanced AI features for learnings and protection method. Okay, but the most existing elevator systems are built using a microcontrollers which fixed scheduling method, which cannot easily change their operations or add smart features. Here the problem in this work is to create a elevator design that work faster, is more secure, and can adjust to different situations, and it's ready for AI use and also keeping passenger safety. Okay, in this project we design an elevator controls on FPGA using a finite state machine. These systems include a floor request handling and priority scheduling method, emergency stop and overload detections, automatic door timing, and floor number display, the passcode access for special features, and the fire alarm mode. Okay, so this new idea in this work is to use the speed and the flexibility of the FPGA hardware along with the FSM designs that can later control to AI for learning passenger habits and predicting moments needed. Okay, so this makes the safety quick and safe and adaptable. So this designs is written in Verilog HDL and tested in ModelSim and implemented on Xilinx FPGA board. We analyzes the performance by checking response times and scheduling efficiency and safety accuracy, and the result shows it is suitable for future smart building usages. Okay, so here we can verify the reference paper. Okay, so this is one of the reference papers we have used for with the support of BLDC motor based elevator systems. Here also it will be generating with the FPGA based architectures. Okay, so this is the architectures. Here they will be taken a power source from the smart grid and used with that in a BLDC motor. Okay, so but here the controlling method used with the FPGA kit. Okay, so in this architectures, it's not having a special features of this floor request handling and priority schedulings, emergency stops and overload detections, automatic door timings, and floor display and passcode. Okay, so this is a completely a normal traditional elevator design. Okay, so in our proposed features we have included this all the thing. Okay, and we have some other reference papers also. So this is a additional reference paper, design and development of elevator assistant based on human traffic, and efficient design and control of the multi-floor elevator systems using PLC, and elevator control chip design, and this one, the fault protections and the elevator door systems. Okay, and this is a 4-quadrant operations of BLDC motor suitable. Okay, and this is a N-floor elevator control systems using PLC, and research and design of elevator door circuit monitoring devices, and simulations of the elevator control with the weight sensing mechanism using VHDL. Okay, so these are the reference papers we have used, and finally we come up with the novelty architectures. It will be present with here. Okay, so this is our FPGA based FSM design for elevators. Okay, so here we have taken a BLDC motor for up and down control request. Okay, so additionally the key features include in the overload. Okay, and this is a door open door timing request method. Okay, and this one is for up request and this one is for down request. Okay, so this elevator designs purely designed for the 8-floor design architectures. Okay, that's why it will be mentioned here 8-floor up request and 8-floor down request. Okay, so and the next features is a fire alarm. okay, and passcode generations and emergency stop. Okay, so using this method we have developed a controlling pattern Verilog HDLs, okay, and we have simulated this work in ModelSim and synthesized this work in a Xilinx FPGA. Okay, so here for this FSM based elevated designs, okay, so we have created a FSM architecture. This is a FSM for this design. Okay, so here initially we start with the init state. So when the start came, first of all we will check the passcode access. Okay, so once the passcode access, it will be success, so then only we move to the flow request. Okay, so here the floor request, it will be waiting, okay, in the ground floor. Okay, that is a normal stable floor. Okay, so once the floor it will be requested, then it will be moved to the priority scheduling. Okay, so why? Because here we need to give priority for all the floors. Okay, so the same time we will get a different floor request. Okay, so for this problems here we are solving, that's why we creating a priority scheduling method. Okay, so if you got any one of the floor, that method also will be checked with the priority scheduling method. Okay, that means any one floor up request and one floor down request also will be checked it here. Okay, so after this priority scheduling method, the floor request will take to move the floor from requested floor. Okay, example floor 1 or floor 2 or floor 3 up to floor 8. Okay, so if moved any floor, okay, and it will be shifted to the door timing. Door timing means when it will be used means, so it will be open the door and it will be close the door. Okay, it will generate a control signal to the BLDC motor. Okay, and at the time of door closing, it will be detect the overload detections. Okay, so once the overload detections equal to 0, then only the data of door BLDC door closing method, it will close the door. Okay, and then it move to the floor request again. Okay, so this is a normal process of operations, but here in the testing features we have added one floor request up request and one floor down request and multi-floor request, and at the same time up and down multi request. Okay, so this kind of features we can possible to check. Okay, after this we have used the priority measurements in the sensing features of fire alarm, okay, and emergency stop, okay, and the passcode error. Okay, so this kind of the features we have used here. Okay, and the priority scheduling method, it's also having the floor request bending method. Okay, so at the time if you got a 2 request, okay, so if you are stable in 3, okay, at the time you got a request from 8th floor and also for first floor, so we are analyzing the features in the priority scheduling. Okay, so first we and given permission to the priority floors. Okay, and the bending floor also we need to give priority in the second. Okay, so that's why the floor request bending module, it will be added here. Okay, so here we are checking the conditions properly as per that. Okay, and then we executed this method also. Okay, now we can verify the Verilog HDL coding part. Okay, so this is a top level design. Okay, and this is a elevator design for test bench. Okay, so here internally we have created the test sequence. Okay, single floor up request and single floor down request, multi floor in same directions and multiple floor in different directions. Okay, and this one is a overload test. Okay, and power failure test. Okay, and this one is a emergency stop test. Okay, so these are the tests we can handle here. Okay, so in this top model we coded as per the state machines. Okay, so this code we have simulated in ModelSim, okay, and verified all the features. Okay, so here, so the first one is a up request. Okay, so here first one is a up request to 5th floor. Okay, so once we received the acknowledgement from the request enable, okay, so here we copied the data of up request and down request, okay, and initialize this request acknowledgement, okay, to make a request enable 0. Okay, after that we start the process of the floor display, okay, with support of moving the state machines. Okay, so these are the state changes, okay, state change and previous state and floor request state. Okay, so initially we start with 2, 3, 15. 15 means it's a priority scheduling state, and 3 means it's a floor request state, and 9 means it's a floor 5. Okay, so the first floor, here it will be moving, right? Here you can check the current floor. Okay, the same output it will be displayed in the floor display. Okay, so at the time the BLDC motor up controls, it will available. Why? Because we need to move the elevator system to top floors. Okay, 0 to 5. Okay, so here the floor display it will be showing the lift moment, okay, smoothly 0 to 1, 2, 3, 4, 5. Okay, so then we start the process of elevator door open and elevator door close systems. Okay, so this is a door open and this is a close systems. Okay, so once it will be finished, okay, so this state machines automatically came to 13. Okay, so 13 is a floor request state. Okay, so that is a door timer. Okay, so this is a door open and this is a door close. After that it will become with a floor request state. Okay, and checking the second conditions if it is any available or not, otherwise it will requesting to the input the floor acknowledgement. Okay, so the process is completed. Okay, so next the verification module, okay, it will be generating the data for down request. Okay, so this one, so okay, the second floor. Okay, so once we received it, okay, so here the down request means here bits available, right? So here it will be take for 8 down to 0, that is a 9 bit. So ground floor, first floor, second floor, third floor, fourth, fifth, sixth, seventh, eighth. Okay, so here you can verify it, the one available in the second floor. Okay, so here it will be requested. So now we start with again. Okay, so now we are in 5th floor. Okay, so now we need to move for 4, 3, 2. After that we need to open the door and also for close the door. At the time of door closing, all the times it will be checking for the overload detection. Okay, so if the overload detections is failure, okay, so here this one, so the BLDC motor overload. Okay, so if the overload detections is failure, that means it will be showing 1. Okay, so it maintaining in the same state. Okay, and it will be creating a alarm. Okay, so that is the next features. Okay, will be verified it. So the next test sequence is multiple floor in same directions. Okay, so here we are generating the up request for 3rd floor and also for 5th floor. Okay, so here this one is a 3rd floor, 5th floor up request. Once it will be received, okay, so here we are checking the up control request and down control request. Okay, so first which we need to given a priority. Okay, so the floor control request, it will be given to 3. Okay, 3rd floor. Okay, why? Because we are in 2nd floor. Okay, we need to given priority to the nearest floor. Okay, this one is a 3rd floor. Okay, priority. Okay, after that the data moving to the 2 plus 1 equal to 3. Okay, so here 2 plus 1 equal to 3. Okay, so now we need to do again door open and door close. Okay, so immediately we are not requested any floor acknowledgement. Okay, we are not generated any floor acknowledgement at the time. Now we checking the internal request, that is a floor up request and floor down request, right? Okay, so that floor request available or not. Okay, so if it is come with 0, then only we can move. So we are exoring the operation here. Okay, the up request check. Okay, with the same floor, current floor value. Okay, so here once it will be XORed, so here XOR means it will be come to 0, right? So 0 0 1 means the same value it will be present with 1, sorry 0, and different value it will be present with 1. Okay, but the same value it will be XOR means, so it will become with 0. So that's why the 3 it will become with 0 here, and 5 it will become with a 1. Okay, that's why the next priority goes to 5th floor. Okay, so here the process again it will be started with support of the soft request enable. Okay, it will be generated internally from the controller. Okay, so then we move to 3rd floor to 5th floor. Okay, with support of 4 and 5. Okay, and we start with the same door open and door close method. Okay, so now it will be completed. Then we request to the model, that is a floor acknowledgement. Okay, floor acknowledgement, it will be initiated. Okay, so then it will take time for some delay. After that it will be started for different directions. Okay, so multiple floor in different directions. So now we received the data for up request 8th floor and down request 2nd floor. Okay, so now we are stable in a 5th floor. Okay, sorry, 1st floor. Here 1st floor, down request come with the 1st floor. Okay, so now we are in 5th floor. Okay, but here we can check the conditions, so which one it will be larger and which one it will be smaller. Okay, but this controller it will given a priority to the 1st floor. Okay, why? Because the down is always priority. Okay, and then it will be given 2nd priority to the up request. Okay, so that's why the elevator design continuously move to down part. Okay, so here 5 4 3 2 1. So once it will be finished, okay, so here automatically the doors will be open and doors will be closed. Okay, and then we checking the 2nd conditions with using the same XOR operation. Okay, but not in the same up request data check. We are also checking in the down request. Okay, so here the down request come to 0. Okay, up request only bending. Okay, so which floor means it's a 8th floor. So the down request, up request, right? So it will be initiated to 8th floor. Okay, so here that's why the data it will be moved to 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th. Okay, with support of the PLDC motor up control. Okay, once it will be reached, it will be open and close the doors. Okay, and the next thing is fire sensor test. Okay, so fire sensor test means here it will be available, but at the time we need to initiate floor also. Okay, so here we initiated, the floor number is 0 1 2 3 4 5. Yeah, 5th floor initiated. Okay, currently we are in 8th floor, so we move to the 5th floor. Okay, at the time the fire sensor it will be activated. Okay, so first of all we need to given priority to the fire sensor. Okay, so that's why we immediately move to the fire alarm state. Okay, so here we enable the alarm. Okay, here. Okay, and doors automatically open. Okay, already closed. Okay, and we initiated the alarm signal. Okay, it's some duration, it's creating some durations. Duration means here we created a delay. You can easily change the delay for this controls. Okay, so fire sensor and BLDC motor and input power and emergency stop. Okay, so all the delays we can possible to create or change easily. Okay, here after this fire sensor mode, we need to check for the overload test. Okay, so the overload test at the time of door closings, it will be checking the value. Okay, so here we moving to 5 to 6th floor. Okay, at the time the elevators, it will be open. Okay, but the before closing the door, it will be checking the overload detections. Okay, here the BLDC motor generated a overload sensing value. Okay, so now we created a alarm in the beep sound. Okay, so it's a pulse mode. Okay, so this is a beep sound. Okay, so immediately creating response to the human. Okay, so if anyone moves down, okay, so immediately we stop the BLDC motor overload. Okay, and we close the door. Okay, and then we move to the 6th floor. Okay, okay, so now the next test is power failure recovery. Okay, so at the time of power failure mode, okay, so that is a test number 6. Okay, so test count 6. Okay, so here we need to wait up to in the floor request state. Okay, okay, so it's continuously checking the power value. Okay, so if it is a power came or not. Okay, so immediately it will be boost the lift. Okay, so here the input power suddenly it will be goes to high. Okay, so at the time it's waiting here. Okay, so once the power it will be came again, it's come to normal. Okay, so then it will be moving to the 2nd floor. Okay, so it's creating some delay. Okay, so then only it will be moving to the 2nd floor. Up to that it will be waiting in the 6th floor. Okay, wow. So then next one is the emergency stop. Okay, so once it will be stopped created. Okay, so this one. Okay, so once it will be enabled here, the up request and down request. Okay, so here the 2nd floor to 1st floor. Okay, so at the time emergency stop signals, it will be enabled. Okay, so here this one. Okay, once it will be enabled, immediately we sensing the value and we requesting the data. Okay, so here the continuous requesting mode. Okay, so but it's not switched off. Okay, so emergency stop, it's not switched off means, so immediately we open the door. Okay, open the door and not need to close the door. So continuously we request to open the door. Okay, and once the emergency stop it will be closed to 0, then we close the door and we move to the 1st floor. Okay, and again we need to open and close the door here. Okay, and finally, so if we not received any input, okay, that is the last test case. Okay, so if we not received any input for certain time durations, we need to go for the default flows. Okay, so here that's why we created a delay here, so that is a ground count. Okay, so if we request continuously, it will be reset automatically. Okay, so if it is not get any request, okay, so it will be continuously overflow the count value up to 999. Okay, so then the elevator, okay, smoothly move to the 0th, that means the ground floor, and door opens and close and it will be wait in the same floor. Okay, so then after it will be not initiated anything, it will be waiting up to the request. So once you are initiated any request here, okay, so it will be operating again. Okay, so it will now it will be in the sleep mode operations. Okay, sleep mode or ideal mode. Okay, so whatever it is, we can name it. Okay, so this work we have synthesized in Xilinx Vado Attic 7 FPGA. Okay, So here this all the logic size it will be take. Here it will be take very less logic sizes, LUT equal to 258 and flip flop equal to 102 and IO equal to 81 and BUFG equal to 1, and this one the worst case delay equal to 4.68 nanoseconds, and power it will be take very minimum 0.139. okay, so here we can check for static power and also for dynamic power. Okay, and here you can analyze a RTL schematic for this elevator design. Okay, so this is a design architecture. So this is a completely FSM. Okay, so that's why it's creating all the thing in a multiplexes. Okay, alarm register, current flow, BLDC motor, up down, elevator door close, elevator door open, and floor acknowledgement. Okay, this one is a request acknowledgement register, passcode error register. Okay, so yeah, here initially we test the passcode also here. So once it will be correct, then only it will be moving to the floor request. Okay, so otherwise it's maintaining in the same state and it will be showing the passcode error. Okay, yeah, that's it. And here for advanced features we can do with the 19 different features elevator design also, which means floor request and priority scheduling, emergency stop, overload detections, door timer and floor display, passcode access, ideal optimization, performance counters, fire alarm mode, door obstructions tray, and remote admin request, sleep mode, and predictive pre-positioning, tamper logout, and speed versus load, and voice command interface, auto diagnostic mode. Okay, so these are the features we can possible to customized for your features. Okay, so that is a future model. Okay, if required we can customize the code and we can possible to give. Okay, so this features it's suitable for a good publication. Okay, and we have written abstract document for this project. Okay, so here this is a title and base paper proposed abstract. Okay, so objective of this project. Okay, and existing systems, related notes, disadvantages, proposed systems, block diagram descriptions, all the models and state diagram descriptions. Okay, and related notes for VLSI, and finally come with literature review and references. Okay, thank you.